We'll see. I don't think it'll take the whole class period. Look at your stapled worksheet, guys. Okay. So, one of the things about the periodic table is that it's arranged, you know, like if you look at a calendar, you have your Sundays, you have your Mondays, you have your Tuesdays, and all Sundays are similar, all Mondays are similar, I hate Mondays, Tuesdays, etc. And that's the same thing with the periodic table, okay? So the periodic table, for instance, all these guys under hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, they're like Mondays or Sundays, okay? They're all very similar, okay? And that's called the law of periodicity. And the reason it's called the law of periodicity, for instance, it wraps back around. For instance, the days of the week, you go Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And then it wraps back around. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And it wraps back around. And that's how this is arranged. So again, remember that the whole number is the number of protons in an atom of that type of element. That's what the whole number is. And we'll be talking about the decimal number tomorrow. Pick up handouts, Steve. So, that has consequences. I mean, not coming in a little late, but the of the way the periodic table is arranged. Okay. Now we're not going to do it as part of today's lab, and then Brett, you can't drink in here, right?
I have to sit here.
Yeah, you can sit down. Yeah, just don't. All right. The Mendeleev years ago was the guy who basically arranged these elements, and it's kind of cool because it's thought of in a dream is how he kind of came up with this periodicity. And I know it's kind of weird. So the way that they're so important, we're going to call these groups in a minute, or families. All the elements that are in the same column are family of elements, and they react similarly. Some of you who want to see things fizz or blow up, for instance. The element sodium, some of you guys know that sodium and water will react violently, a lot of energy, okay? And so will its neighbors, lithium and potassium, rubidium, and cesium. And I'm pretty sure the farther you get down that same group under sodium, the even more reactive they are. And yes, we do have sodium metal, but it's safely tucked away in the chem storeroom.
Out there at Castles, we use potassium out there.
Yes, and so, yeah, if you look at where potassium is, it's got the same chemical properties, exactly. So, there are different ways of chunk up the periodic table. So, notice that this periodic table is missing the decimal number for all the elements. Again, in lecture tomorrow, we're going to be talking about that decimal number. But you can see how it's arranged by increasing number of protons in the nucleus of those elements. Okay. So chunking it up. The first important way to look at the periodic table and to divide it is to look for what I call the jag. And so if you want to, I gave you an extra copy of this just in case you want to kind of mark it up. Okay? So if you find the jag, and I've got the jag on the black and white periodic table that I'm going to give you for your test, the small triangle of elements are the nonmetals. And all of these others are the metals. Okay, it's an important jag, an important distinction. To me, it's mind-boggling. If you look at this kind of handful of elements over here in the upper right-hand kind of triangle over there, there's not very many of them, but there are some big players. There's carbon and oxygen and nitrogen and phosphorus over here. They're nonmetals.
Hydrogen's considered a metal?
Hydrogen actually, on my black and white periodic table, appears twice. Okay, hydrogen appears, I know, it's kind of strange, but it's on purpose. Hydrogen appears over here, okay, and hydrogen also appears over here on my periodic table. On my periodic table, and that's on purpose. Because sometimes it behaves kind of like, oh, and I can't make that go away, but you guys know what's under hydrogen. Then we have lithium, sodium, potassium. Sometimes hydrogen behaves like those guys. And then sometimes hydrogen behaves like the halogens, fluorine, chlorine, bromine, iodine, and acetylene. So I have it twice. Okay, now another important kind of group of elements are the elements along the jag. So I've marked the elements along the jag, and if you want to kind of mark them on your sheet, you can. As I mentioned, the exercise, which is your ticket out of here today, you're going to be kind of identifying what these elements are. So there's a group of elements called metalloids, okay? And they are basically, kind of as the name might imply, they're kind of metal, they're kind of non-metal. They're metalloids. And so I have boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. Now, here's the deal. You might Google metalloids, and you might come up with a slightly different version, different set, but it'll be along the jag. And it just depends upon what chemist you talk to, how they're feeling that particular day. That's what it seems like. So these are metalloids, or semi-metals. All right. Okay. So this slide is just trying to highlight how important, like when we applied the law of periodicity, how important the elements are that line up in the same column. They are so important. Okay, you'll hear those elements called groups, the set of elements called groups. And I want to kind of highlight, if I can, okay, each group has a group name. So, for instance, the group name here, where hydrogen is, that's group 1A. Group 2A is the column starting with beryllium. Then I'm going to kind of jump over the indented elements, going over here, group 3A, starting with boron, 4A carbon, 5A nitrogen, 6A oxygen, 7A fluorine, and 8A starting with helium. So those are the group designations.
Does that ignore the jagged line?
Right. What Russ is pointing out is, notice that when we go to say what group an element is in, it's kind of like we switch gears with regard to, is it a non-metal or is it a metal? So this is to say that all of these elements are in group 4A. Are some of them, I guess one of them is a non-metal, one of them, or maybe two of them are metalloids, and then the two bottom ones, tin and lead, are metals. So, yep. Okay, so another important designation is actually the groups that I just said. 1A, 2A, skip a bunch. 3A, 4A, 5A, 6A, 7A, and 8A. Okay, those are what we call main group elements. The thing about main group elements is they all have, what they all have in common is they all have the letter A in their name. 1A, 2A, skip a bunch. 3A, 4A, okay? And this is what you're going to get for the test, okay? So notice and sometimes there's an alternate designation that's kind of running across up here, okay? But you'll have this. The A groups are the main group elements. And again, notice the main group elements when you get over to there to what we call the kind of the P block elements, 3A to 8A. Notice those main group elements, they have all of the non-metals and just a few of the metals in that block. But just different. All right, now we get to the P groups. The P groups. Remember, up and down is a group, sometimes called a family. So the B groups, sorry, not P, the B groups. So we have group 3B, 4B, 5B, 6B, 7B. 8B is collectively those three columns, and then we go back to 1B, 2B. Don't ask me. Okay. So instead of calling them B group elements, what you're going to see, that particular set, that block right there, they're metals, and we call them transition elements. Sometimes we call them transition metals. Let's see if I can change my color here. Kind of bugging me. Transition elements or transition metals. Okay, and that is this group right here. All right. So, up and down are groups, and don't worry, I haven't forgotten about those kind of two tag-along things at the bottom. We're coming up on those. Going across are important too, but they're called periods. Okay, so going across are periods. And you know what period they're in, and I really like this black and white periodic table that I've given you. You know what period they're in because the numbers are over here. Okay? So, for instance, in period 1, we only have hydrogen and helium. In period 2, lithium, beryllium, boron, carbon, nitrogen, etc. In period 3, sodium, magnesium, aluminum, silicon, etc. In period 4, finally, is where we get some of those transition elements. Okay, period 4, that's where the transition elements begin. Okay? Now, it's kind of like days of the week. You know, are they in the same week? You know, is my Saturday in the same week as my Monday? Yeah. Are they very different? Yeah. Okay. All right. So, I need to talk about those trailer honors down here. You can see on the title of the slide, the first trailer honor, which is a period. Oh, sorry, yeah, period. Okay. Let's look at CE. You see CE down here? You look at its whole number is 58. You're like, all right, 58, where's 57? So you start to look and you see 57 is the element with the symbol La. And then in that same period, we go to atomic number 72 with HF. You're like, what the heck? Well, if you look down here at what we call the Lanthanide Series of elements, that's where your missing elements are. So it basically jumps from La to CE to PR to ND to PM. You got to see what I mean? Okay. It's kind of inserted. In fact, sometimes I've heard people say that it would be nice to, here I'll kind of show, I can highlight this. Sometimes people say it would be nice to go ahead and have a three-dimensional periodic table where you have the Lanthanide series coming out of the wall like that. Okay, and then it continues. And the reason we do this is to make our Mondays and Tuesdays and Wednesdays and Thursdays match up. We need to get the periodicity, okay, because when we go down here, okay, we're going to see that we need, for instance, we need lead to match up with all this other stuff, okay? And it's about, which part of the atom is buzzing around in the cloud outside the nucleus? Electrons, exactly. This whole thing of having periodicity is about the electrons and how the electrons are arranged. So we'll be talking more about that. Okay, so that's the Lanthanide series. So in today's homework, if you run into something that says the Lanthanide series, you know what that is, hopefully. Okay, and then the one underneath it is the Actinide series. And we have basically the same thing going on. Okay, so you have, bless you, have atomic number 89. And then notice you need to go down to thorium. I love thorium. It reminds me of the movie. Okay. So then you go down to thorium, 90, 91, 92. Oh, uranium. That's an important one. Okay. And then when you get to the end of the Actinide series, atomic number 103, that's when you jump back up to 104 up there. Okay, so any element in there is part of the Actinide series of elements. All right. So collectively, the lanthanides and the actinides are called the inner transition elements. Makes sense. Because kind of we said that the regular transition elements, we said were these guys. These guys are the regular transition elements. Kind of the B guys are kind of the indented B guys. And these guys are the inner transition elements. All right, so now we're almost done. There's a few groups that I want you to know their name. Okay, a few days of the week I want you to know the name. Now, excluding hydrogen for now, starting with lithium and going down that group, the special name for those are called alkali metals. So you're going to want to know that name. Okay, alkali metals. So this is where, so was it helpful for you guys to have the sheet with you on your test? You want to have the sheet again? Mm-hmm. Okay, so let's do like we did last time. You won't have a formula sheet. You don't need formulas for chemistry. But go ahead and plan to bring a periodic table like that. How's that? And I'll provide a clean one. I don't know if you want to. Okay, let's read. Okay, so yeah, like I see some of you guys marking up your periodic table. Just be thinking about how you want to do that because you can bring it to your test. Okay? What the heck? All right. So you're going to want to know that group or that family of elements as the alkali metals. The family you're going to want to know is the next group, which is the alkaline earth metals. Okay, alkaline earth metals. And then we skip a bunch. And so clear over here, I want you to know you might recognize the name halogens because they are oftentimes used as the gas in light bulbs. Okay, so what's called group 7A, clear over there almost to the end, are the halogens. One more group to know is the one right next to it. Okay, now this last group over here, this last column on the periodic table, they actually have 3 names. Okay, they go by noble gases, rare gases, or inert gases. If you go to use a medicine, okay, and you look on the package and it says active ingredient, inert ingredient, what does inert mean?
Not doing it.
That's right, inert ingredient means it's not doing anything. And that's what they all have in common. And I told you how they line up has to do with the electrons, so it's kind of a cool thing. We'll talk about all of that, the elements in group 8A, the rare gases, noble gases, inert gases, 3 names for the same group. They are inert. They don't like to play with anybody else because they're quite fine being who they are. Okay?